Hey there! Welcome to Formula One Math, where maths is quick, clear, and easy to learn. Let's dive in and make numbers simple together. Let's start with the chord. A chord is a straight line that connects 2 points on the edge of a circle. It doesn't have to go through the center, but it stays inside the circle. Think of it like this. If you stretch a string across a circle from one side to the other, that string is a chord. If the chord does go through the center, it has a special name. It's called the diameter. So every diameter is a chord, but not every chord is a diameter. Why is it important to know about chords? Well, if a chord subtends an angle at the circumference of a circle, and it does the same at another point on the circumference, those angles are equal. It doesn't matter how many angles the chord creates. As long as it's the same chord and the angles are at the circumference, they'll all be equal. So, as you can see, all the angles formed by the chord are equal. Each one measures 51.9 degrees. Also, if a chord creates an angle at the center of the circle and another at the circumference, the angle at the center is twice the angle at the circumference. Let's move on to tangents. What's a tangent? A tangent is a straight line that touches a circle at exactly 1 point, and only 1 point. It doesn't cut through the circle, it just gently touches the edge. At the point where it touches, the tangent is always at a right angle, or 90 degrees, to the radius of the circle. When two tangents are drawn from a single point outside a circle, they're always equal in length. So if tangents CD and BD both touch the circle and meet at the same point outside, that means CD is equal to BD. This happens because both lines are stretching from the same point and just touching the circle at one spot each. That makes them mirror each other. And when a diameter forms an angle at the circumference, that angle is always 90 degrees. In other words, any angle made from the ends of a diameter to a point on the circle will be a right angle. This is a special property of circle theorem. Also, when there's a quadrilateral inside a circle and all its corners, or vertices, touch the circumference, we call it a cyclic quadrilateral. In this kind of shape, the opposite angles always add up to 180 degrees. So, for example, angle BDE plus angle BCE equals 180 degrees. The angle between a tangent and a chord is equal to the angle in the opposite or alternate segment of the circle. This is called the alternate segment theorem. So in this case, angle ECD is equal to angle CBD. Now be careful with this. The angle in the alternate segment can be anywhere on the circumference, and the alternate segment theorem still applies. As long as the angle is in the opposite segment from the tangent and chord, it's equal to the angle between the tangent and the chord. So again, angle ECD equals angle CBD, no matter where that angle on the circumference is placed.